everybody. Me and Soren, my co-founder of Cataer, we are based in Copenhagen. We were working for Novo Nordisk. I don't know if everybody knows what it is, but you must know Eli Lilly, and Novo Nordisk is the European competitor. And we loved innovating, and we decided to leave and focus on solving technology problems for the pharmaceutical industry. Specifically, as Robin was mentioning, we have humans inside clean rooms today because we don't know how to do without them. But it's a paradox because the human body is the biggest source of contamination. So what we do is we give humans a robotic body to pilot through immersive headset from a control room. In this way, we keep the best of both worlds, the sterility and precision of robots. That's what you would like your medicines to be, how your medicine should be made, but with the control of humans that know what to do, and we don't have to wait until AI gets there. And through time, we gather all this data, and then we train AI on real operations that we gather from the industry. So we cannot use coffee preparation or folding t-shirt data for these robots because it's about preparing your medicines. So that's how we pave the way towards that. And again, it's not only limited to the pharmaceutical industry. We are focusing on that because we have a direct founder market fit. But for sure, one example is satellites. We need the same kind of cleanliness to make sure that they are produced correctly.
Right, and one of the things that you're doing with the clean rooms is you're building these on Earth, but Priya, you are in the middle of a massive project through Operation Period, where you're bringing, tell us what you're doing. I don't want to
Hi everyone, my name is Priya. I am an aerospace engineer and now designing life support systems and technologies to keep humans alive in space. The work that I do at Operation Period is building the first robotic uterus on Earth and for space applications. It wasn't until 2023 that real menstrual blood was used in menstrual health research. And currently, in terms of life support systems on the International Space Station, menstrual blood there's no real way to contain menstrual blood. A lot of female astronauts are forced to take oral contraceptives that increases risks of cardiovascular diseases, strokes, blood clots, thrombosis, all published publicly by NASA, who stated that long-term effects of menstruation and suppression have never been studied before. And as we look at the future crew of sending women to space and also looking at the data of how menstrual health is decades behind every other field of medicine here on Earth, our robotic uterus will be going on an upcoming space flight. More details on that are the part under NDA, but we'll be going to space, operating the first robotic uterus, looking at menstrual blood dynamics in microgravity. And as an outcome, we aim to create an engineering guide that we want to send to all sorts of space companies across SpaceX, FAST, Blue Origin, etc., on how can we build waste management systems that can accommodate menstrual health, and how can we categorize menstrual health products such as pads and tampons and categorize their efficiency and performance in space versus on Earth. This robotic uterus will also be licensed across medical centers, clinics, OBGYNs here on Earth. The goal is to help with clinical testing. There is no real way to diagnose a lot of menstrual conditions without invasive surgery currently. A lot of conditions such as endometriosis, PCOS, vaginal cancers, even heavy menstrual bleeding that affects 20% of all American women and 40% of Asian and sub-Saharan women can't really be diagnosed or treated without invasive surgery. And invasive surgery has 9 months of recovery time, so our robotic uterus helps us simulate all of that and create all of that and test all of these different conditions. We've also currently been in conversations with Walmart and P&G about bringing this robotic uterus into the market of menstrual product testing and menstrual product development. The area and the market of building and creating menstrual products is extremely unregulated, and currently they use eyedroppers with water to test pads and tampons. And there has also been recent lawsuits on issues around transparency of what they make tampons with and what they make pads with and how harmful it is to put in our body. And so our robotic uterus comes into that market of being able to improve product testing and be a standardization and a baseline for how we create menstrual products for billions of women here on Earth.
Cislunar, what's interesting is you come from the talent perspective as well, where you are not only hiring into the space economy, but you're also building these incredible foundries at the orbital level. Tell us more about what you're doing.
You know, it's really fat. Like for me, I been a sci-fi lover my whole life, right? Growing up in the '80s, and you know all the sci-fi movies and TV shows. But I never thought I could exactly Trekkie, yes. Star Wars, yes, Stargate. All of it, right? And you know all of that imagination and that creativity. And now we're building those things in real life, and that's so. First of all, I never thought I could work in the space industry. I'm not an engineer. You know, I don't have clearance, right? And those were kind of the gates that were apparent to me. So I couldn't get through those gates. Just I didn't go that path, so I never could work in the space industry. But then it was about 5 years ago. I mean, this commercial space industry, you know, many thanks to SpaceX for kind of blowing that door wide open for the rest of us. But you know, the industry needs all kinds of people, and we need all kinds of voices in order to not only just make a company run normally, HR, you know, communications, sales, but space is one of those places that's for all of us. Like, and we should, you know, really consider how we're going to go to space in the right way and do things in the right way based on everybody's voice. And so, from a talent perspective, for me, it's more about extending an invite to people to let them know that there is quote unquote space for you in this industry. But then it's very, you know, it always points back to Earth and what we're doing for ourselves and for humanity. So cislunar, you know, we want to be, eventually we want to be like the steel mills of space. You know, there's an industrial revolution that's going to happen. There's an economy that is growing. It's closer than most people think. But it's
already,
here.
Right?
It's
There's
already
a lot of
here.
Space waste and trash out there.
Exactly, and you know that's the thing we were talking earlier. You know, when we first went to space, we didn't have a recycling plan, right? We just went, and we kind of just leave stuff there. I mean, most satellites are one and done, right? You make it, you throw it up there, you let it do its thing, and then it dies. There was never a plan for what to do with all of that. Even on the moon's littered with stuff that we just left behind, mainly because we couldn't bring it back. So our plan was to use that as sort of a starting point of resources for us using our foundry. So I'll get kind of nerdy and Trekkie real quick. So our engineers developed essentially the first version of a tractor beam, if you know from Star Trek. But essentially we're using electromagnetics and induction heating to take materials in zero gravity, melt them down, and control that in zero gravity. So you can imagine, you know, you've got a molten ball of metal. How do you get it into a mold to then create, like, building raw materials for building, or metal propellant, things like that. So that's what our foundry is designed to do. We built it. We have a working version of it, and that to me is how we started to create this manufacturing economy in space where, you know, in one way, and so I'm also here as part of kind of Ready, Set, Jet.
So my group with our partners trained rover to go to Mars. So we used all the inference AI to train it. You know, we simulated what the Mars environment would look like, and we had, you know, little pretend rovers running around, and we would practice on rover on Mars. As we were doing that, we were thinking, you know, this is something that is going to happen sometime soon, and who out there is investing in space startups? And it was actually 6 years ago, we opened up the Space Accelerator. We were, I think, the first, maybe there's someone else before us, but we couldn't find anybody who was investing in space companies. So we opened up, as part of Amazon Web Services, a space accelerator. And so what we would do is every year, and we did that, we've been doing it for now 6 years, we would invest in companies who were doing something around space. So one of the companies we invested in was a company that was trying to make water in space. Because obviously, if we plan on ever going to the moon or living on Mars, you obviously need water. And so we invested in that company, still going today. The other thing we wanted to test was sending hardware up to space. So we sent an appliance, which is simply a box, a hardware box with AWS Cloud on it. We sent it up to space to see how it would perform, what parts would have problems. Using AI simulation, we thought we simulated what would happen, but then we actually sent it up to Mars. So we invested in, several different companies, and I think it's really interesting.
Did it happen? Like, did
Yeah.
what you think would happen?
Not everything happened in the simulation, but I guess let me say it this way. Everything we simulated would happen, happened, but more happened. So it didn't catch everything, and that just trained our learning models to do more. Obviously, we're doing a lot of this in conjunction with NASA and other companies as well.
So what Sandy was seeding early on, and you all are at the different phases that you are, but what are you looking at?
This is a fantastic panel. Thank you, Robin. Thank you, RedThread X. Because for an investor, I mean, this is where we hear, what's happening, what's hot, what's not, and compare it to the things that we're seeing. And what I love about hearing from you, Sandy, is how, and I would agree with, I think all three of us are very similar age range, because we all grew up kind of watching the sci-fi and wanting to be a part of it.
When we grow up.
I know. But I think what's interesting here, and also for all of us in the room, is that it was only 6 years ago when you couldn't, so how, that's nothing. Like how quickly we've come to a place where everyone's hot on space, and not only hot on it, but what you mentioned is that space is like full. I mean, I talk to people on a regular basis who say, oh yeah, we're really going to space, is Elon crazy, whatever. We're in space. Like there's a lot of activity in space, a lot of trash too. I talked to, there's several companies that are working on cleaning up like waste management in space. I think that's interesting. But the first time I heard that was probably last year in the same RedThread X, one of the panels. We had someone talking about how much trash is in space.
And also, I think we were talking to people in space on the way down.
We were.
Live from the sphere, which was pretty cool.
We were, which was very cool. So I think what's interesting for me as someone looking at investing in more later stage, there's been over a very short period of time a massive foundation laid for the early stage companies who are now running into what many of you know as the missing middle, death, valley of death, whatever you want to call it. These first of a kind technologies who have real loyal believers at the early stages, angel investors, some of you in the room, maybe these people, what you guys were doing, but they come sort of to a point quicker than most industries. They get to Series A and they need more money than their angels and their supporters can give. And you're not going to get a bank who's like, yeah, sure, you want to hang out in space? Like, here's some money. So the capital is lacking in the United States and also where I sit in Europe. So I'm based in Munich, Germany. We are very active in trying to do some of the things that we see in Austin and in Texas. We've got, we in Munich are the deep tech center for Germany. We sort of overtook Berlin earlier last year. As we'll talk after, but there's another company that we're looking at that uses zero gravity to test cancer cells in reverse. I mean, they're amazing. The opportunities are huge.
Well, there's a IVF company, Spaceborne. Have you heard of those guys? Yeah, they're developing sort of a microgravity lab for IVF in zero gravity, because gravity, this is what kind of gets interesting with our metal, for example, when we're melting the metal, and why pharmaceuticals are looking so much, and why, like RedThread, for example, because there's no gravity, things tend to crystallize in a much more perfect final form factor, and so, because gravity stinks for most of us, right? We can feel it. And so up there you can create a drug that's much more effective because its crystalline structure is perfect. as opposed to here. And so where one drug down here is maybe 80% effective, up there it could be 100% effective. So now you change the game in terms of costs and how much you actually need to take. But yeah, totally fascinating.
And what's interesting is another thread that connects many of us is this Ready, Set, Jet and the Space Council. And here's the baton. Sandy has received, everybody here is received, except for Marco. Marco, we're going to pass the baton to you. But this is the first space NASA certified product in space, and I went to the launch, but the launch kept moving a couple days, so I wasn't there for the physical launch, but I was in Cape Canaveral on the day that it was supposed to launch, and we had a dinner with the chief strategy officer of Axiom Space, and he was saying that when you manufacture fiber optic cables in space and you bring them down to Earth, they're 1,000 times more efficient because everything is multiplied by the force of gravity in physics. And so this microgravity piece is sort of like the new gold rush. It's like how can we be more efficient? And so that's really kind of the exciting piece that everyone's working with. And do you want to talk about being an ambassador for Ready, Set, Jet and what it means to you to be able to bring these products to space?
Of course, yeah. So met Shalini a while ago, super dynamic, awesome women, and stands for supporting other women in the space and bringing people together and the idea that space is for everyone. Ready, Set, Jet is a really cool brand that I am an ambassador for on the Astro Council, and it is the first makeup brand that was certified in space. It spent 20 days on an Axiom 4 mission, taken up by female commercial astronauts to space. Yeah, Peggy Whitson. And it has also been to 2 analog astronaut simulations, I believe one in Utah. I forget where the second one is. And so this idea of making makeup in space is really cool and really fun, and I think also improves and taps into the cultural aspect of space and being able to have something that people can relate to when they think of something so far and distant as space, something that's not as accessible and reachable for the common individual. And then when you bring the aspect of makeup into that picture, it all of a sudden becomes more fun and exciting and something that can be used to convince the public of why space is important and cool and the next big thing. And I think that is amazing.
So it's a good product too. I got some of this at Ubaldo. Yeah. And I use it. It's really nice. Nicely done.
And there's this commercialization piece, but there's also when you are up in a high radiation, low gravity environment, it matters what you put on your skin. There's also a wound healer that she's about to release, which has defense applications. But then also, if you cut yourself in space, what are you going to do? You could use Neosporin. I don't know if NASA has certified Neosporin. Yes. But Marco, I want to come back to you to kind of talk about how you're bringing physical AI, because the other thread that we wanted to talk about is this software-enabled hardware, because software alone will not save us from ourselves.
Yeah, so I connect with what Sandy was saying before, that they were able to encounter all the simulated cases, but obviously new cases from the real world happened. And that's exactly what brought us to decide to go first from a very, let's say, harmonized approach between human and robots, so working together, making the robot as a body controlled by the human. For one reason, we need to gather data, because we cannot make errors here. If we are producing a car and a component of the car doesn't work, worst case the car doesn't run. If there is an issue making medicines, you can make several people sick, if not worse. So the idea is that we can pave the way sustainably by gathering this data. So the real way for us to go, we get asked why the operation, why not directly AI? Because the models are out there. Honestly, every day there is a better physical AI model or a chatbot model, but what is missing is relevant data. So if you never experienced this kind of environment, if on YouTube there is no videos about how to produce medicines, the AI won't understand how to execute it if they look just at those data. And usually pharmaceutical companies are very how do you say, they like to keep their data. They don't like to share them. The production lines are absolutely not connected to internet because they cannot even take the risk that somebody can hack into them. So that's why we love the excitement that our field got. I mean, me and Soren, when we were studying some years ago, we would not have expected this kind of craze about physical AI right now. But it's important for us to distinguish also between the hype of seeing a humanoid, feeling that the future is here, and instead knowing that the humanoid can actually do those things. So I would say that we are paving the way there, but it's still a long way. And as before I was talking with Ubaldo about is, we still have to be very human-centered. We cannot think that humans are out of the equation right now. Absolutely, it would be a terrible mistake.
Right, which is why alter echo is not alter ego. It's just an echo of our human selves. Sandy, your work is now stretched to Web3 and blockchain. Tell us about how you're layering that into what you're building as the next big thing.
Yeah, so we do a lot of work in AI and blockchain. And if you guys know blockchain is an independent way to store data. It's stored in blocks, so no one company has control of it. And so one of the things that we've been looking at with space is because of all the space trash that's up there are now companies bringing the trash down, and the trash actually has value to it. And so people are wondering, well, whose trash is up there, right? Because when people bring it down, they want to charge them a fee, but then when it comes down, they get the results of whatever that trash is. And so what we've been doing is tokenizing the ownership of the trash. So blockchain provides the ability to claim ownership. So let me give you an example. When you log into Google today with your username and password, you're logging in, but you're actually renting the ability to leverage or use Google. That ownership of that name and address is not yours, right? Because Google, or if you log into Facebook, they can kill that at any time. They could go out of business and you can't leverage it. Well, in blockchain, when you have a login and a password, it's yours. You own it, stored across multiple blocks, multiple data miners. And so it ensures that the person or the company actually owns it. Does that make sense? And so what we're now doing is we're working on being able to tokenize that trash so that when it comes down, we know who the owner is. We can charge them a fee for taking the trash out of space, but also then they get whatever is left, which is valuable in some cases. The other thing that we're doing is we're working with a company called Space. I don't know if you guys know them. They're based out of Poland. As I understand it, I could be wrong, but as I understand it, a Polish scientist is the one who kind of was the first one to come up with the idea about going to space. It's what NASA's space is built on. If you go into NASA, you'll see a statue of him. And the daughter and the grandson of that particular space explorer started Space. And what they're doing is sending into space different items to see how it does in space, as well as to tokenize it, to claim ownership of it. So I'll give you a couple of examples which I think are pretty cool. They sent art up in space to declare ownership. So if we ever have homes in space, homes in Mars, you'll have your art there, and the art is tokenized, so it shows your ownership of that art. Formula One, you guys all know Formula One. Formula One has asked us to build a racetrack for space.
What?
Because they think eventually.
I thought data centers in space were crazy.
So they do believe that one day there will be the ability to race cars in space, but that will be obviously very different. And so, Antor, yeah, and what's the fuel? I mean, there's so many things, right? Like Star Wars, yeah, you got it.
Absolutely.
You got it. And so the really cool thing about this is, so working with Space and our company, which is called Unstoppable, that's doing this, they wanted to get kids involved too. And so while they had professional, aerospace engineers and everything design tracks, they also had children from around the world design what they thought a racetrack would look like in space, what they thought a car would look like in space. I wish I had pictures of them here that I could share with you, because Some of them are super kooky, but I have to tell you, 2 of the designs, Formula One was like, this could be really cool. They were designed by an 11-year-old and a 13-year-old. And what we're doing there is obviously then we're providing ownership, if anything ever happens to that, we're providing ownership of that. And then the last thing we're doing is, if you think about your company today, your company's probably represented digitally by a domain, right? So Amazon is Amazon.com, right? Or IBM.com or whatever that, NASA.com. And so the question was, well, what happens when we get to space? Well, we need to tokenize that digital identity for companies. So we have been tokenizing now .coms, .ais, those domains that will owned by companies. So when those companies get to space, they'll then have ownership of their digital identity in space as well. So thinking, far out, maybe 5-10 years out, but when companies do that, that's what we're working on. So there's a lot of work going on with blockchain and AI in space.
Okay. And I want to ask one more kind of closing question to Sarah, and then I want to open it up for questions. So if you have questions, I know you do, get them ready. But I know, Mark Andreessen many years ago, about a decade and a half ago, said software is eating the world. And now we talk about a dead internet and the software industry, blowing up. What will save the world today if you were to write a big op-ed in the Wall Street Journal?
That's great. Oh gosh, Robin, thanks.
Where should people be putting their investments?
Yeah, sure.
Because
Is this being recorded? Am I on? That was a joke. I'm sterile. I think the point is, I've heard a lot of people say like SaaS is dead. SaaS is not dead, but I think the point is, yes, that software alone is not going to solve the world's biggest problems. So where we've been focused even before the latest, the world blowing up as we all know that it is right now. Even so, 2 years ago when we sort of decided to launch Helena Capital, we were very focused on software-enabled hardware and really these what we call either frontier technologies, which is very space-like, but also deep tech, whether that's biotech, talking about all the different layers and subsectors. It's important, I think, for any angel investors in the room or syndicate investors in the room to recognize that go ahead now if you haven't yet and to start taking those baby steps towards hardware, right? Software-enabled hardware, start sticking your toe into it if you haven't already, because the future, at least I would say the next 3 decades are going to be really guided by deep tech, what we all think of, regardless of which subsector you're focused on. So whether you're ready to talk to companies about what they're doing in space, we tend to invest into dual-use companies, and dual-use, by the way, doesn't always mean military, civilian. It also means on-planet, off-planet. So, and actually in Texas a year ago, I was talking to a guy who was working with the accelerator at Texas A&M, and he said to me, we work with these founders who say putting in a screw for an airplane on the planet or one that's going out into space, it's the same supply chain, it's the same tools that we use. We need to get back kind of to the basics, and I think that's where we are. So the future is talking about these things and understanding on a human element. I agree with what Marco said. It's about the humans having the vision to stack that AI application onto an industrial. I love LLMs. I'm a lawyer, so I'm super happy that it makes me more efficient. But the future is really how AI is going to help us with efficiency and future-proofing these supply chains to keep us on this planet, a healthy planet, and help us to do fun things in space.
Any questions? So questions, go for it.
Yeah, do you
Thank you so much. I'm very proud to be the first one to ask questions.
We're proud of you too.
Technical question from a guy who has no clue. But how do you take trash out of space without burning it into the atmosphere?
I can answer that maybe a little bit. Well, so part of it, so that there are, what we're wanting to do is not bring it back actually.
Okay.
So there's two things, right? Because one for us is we don't need. It's so expensive and heavy to take things from here, right? So there's so many resources. I mean, tens of thousands of things that we could recycle up there, and then you've got asteroids and moon. You know, you have all these unlimited crazy resources, things that don't even exist on Earth. So, but there are companies, almost like tugboats, or that have arms. And we're working with them too, because they would essentially go out and grab this debris
But then you
and then
cover it in something.
bring it.
bigger,
Yeah,
like
so
a-
you would have like a down mass vehicle of sorts, like Dream Chaser space plane, something that could return.
You need to take it out there first, and then you take it down. Doesn't it waste a lot of energy as a result?
Well, that's our yes. So exactly, there's that.
But
That's
I
why
guess
there's a lot of focus on
Sandy's
on
telling us there is
recycling.
a real ROI there in recycling
People
space
want,
debris.
people want to have it brought down for lots of reasons, so energy. Some believe that if it's been up in space, just like with the makeup, right, that has properties when it comes down from space, that it will also have different properties that are
People want to study
also.
that. They want to study that.
They want to research it, they want to see what possibilities come out of that as well.
Anti-aging.
So
It's data.
there is a,
They're 70 years old.
You look good, Robin.
But there is a real big desire to see what the properties are and really do the research, and she really named it, right? AI is hungry for data, and you need that data that we don't have today down here. Like, some of that data would have been very helpful for us when we were trying to get Rover to operate. Had we known about some of the properties, we would have been able to be more efficient.
Anyone else? We're proud of you for asking the second question. You want to come up and will you say who you are and what you do when you introduce yourself?
Sure. My name is Jonathan Josephson. I'm with Quantum Interface. We work with command and control systems, and I control stuff.
Fun stuff.
On a quantum level.
We need
Yeah.
to talk about quantum too. We should-
Yes, we can talk about some quantum.
That would be really interesting. So I have one humorous question, and then Sarah, one specific question for you. The humorous question is, so how many things can you do with lunar dust, regolith? What are the plans with it? It's like the answer for everything, like AI, I think. So everybody here will be affected by that in a massive way. So, in fact, in talking with Leidos, it's like, it's the dust, stupid. That's the answer for everything. So I just wanted your
Get the
comments on
t-shirts.
that. That's right.
That's
right. And then the second thing was, what is the real sweet spot, Sarah, that you're looking for? What's the thing that when you go, yep, that's it?
Yeah.
I mean, short answer is we don't know. Like there is so much. I mean, right now that we've only really used simulated dust here on Earth. There's not a lot of actual lunar regolith. But I mean, we were part of the DARPA loops envisioning how all these companies could come together and build like a lunar architecture base, and what were all the parts and pieces that were related to that. So a lot of that was taking lunar regolith, pulling out, oxygen or other things out of the regolith, the dust. But then what would you do with the sludge after that? And that's where we could come in, for example. Like we could take that and process it through the foundry. Well, exactly.
Barriers.
No, there's companies that would take regolith and make bricks, because we're going to need landing pads.
Yeah.
And so these autonomous rovers would go and just process it on craft, and then drop bricks and make pads. So we don't know.
But what's also interesting is when you think about the moon and the lunar 28 days, and that also is very much tied to the menstrual cycle. So I'd be curious if you have a lunar dust answer based on your research around the uterus.
Oh, sorry.
I don't know how it would tie to the menstrual cycle specifically, but just to echo on the fact that we don't know what the possibilities are, my senior thesis was actually about what we can do with lunar regolith. And it's everything from like creating thread in space to creating composite beams in space. And everything in between can be made with lunar regolith. And there's also the idea of what would a house on the moon look like? It wouldn't really be fancy skyscrapers on the surface of the moon. A lot of it would be underground because regolith is also a really good barrier from radiation. The moon doesn't have an atmosphere, Earth has an atmosphere, so we're protected from the sun, but we're not on the moon. So what would the houses look like? We would have to dig underground, and we'd have to live underground and to come out, and we have to see how long is it safe to stay outside until we need to go back in, unless we've solved the radiation issue. So yeah, there's a lot we can do from thread to composite beams when it comes to lunar dust.
So I guess you're asking the right people. She wrote her thesis
Yeah,
on
by
it.
the way, I never saw it coming that we would be talking about menstrual cycles. They did, it's really cool. I mean, it really blends, it's the human aspect that we have to deal with.
I mean, that's the thing, I think we forget, right? Like NASA, when we went, when we first went, it was all about the mission. And most astronauts, it's work. It's a 24/7 day job, right? And so there never was a lot of discussion around being human in space. But now, regular people say regular, the wrong stuff. I like, because we put these astronauts up here as gods, right? The right stuff, but we need the wrong stuff to go if we're going to make it work for us. If we're going to be able to live and enjoy life. I mean, that's makeup, wellness, sex, drinking, all of that stuff. We're going to do it. Like, somebody's going to do it. And so why not prepare for it? And that's why I think these conversations are extremely important. And menstrual cycles, all of the understanding how our body, because they work differently up there big time, which is what Shelley and Ready Set Jet are trying to help take care of, right?
Yeah, I think apart from that, even the idea of wanting to settle down in space and wanting to, expand our human presence in space can't really happen without thinking of what would the first space baby look like. Can't really happen without leaving half the population behind. The International Space Station was specifically built, and all of our initial NASA spacesuits were specifically built for Apollo astronauts. Apollo astronauts were all of the same demographic. They were men from the military. And now, after women finally, got the opportunity to go to the ISS, got the opportunity to fit into these spacesuits, it's not built for our anatomy. Wider shoulders, wider hips, adds on 80 extra layers of mobility impedance that the spacesuit already gives in the first place. And so it's looking at how can we not leave half the population behind, and how can we make sure more than half of the population can be healthy in space and not get diseases and cardiovascular risks and strokes.
Amazing. I did have the question. No, that's great. This is super interesting for me as well, just to listen. So we are more, I would say, what we look for and what we're focused on, we're slightly picky and we're later stage. So we don't sort of spray and pray and invest in 200 companies. We are looking for really 15 to 20 companies that are, unfortunately, we want them to be doing everything. So we want to make sure that they've got decarbonization solutions built in or embedded into their technology. We want to see that they're solving massive problems. This can be across automotive, aerospace, which is what we're talking about here, also quantum. We're looking at compute, we're looking at robotics. And I would say two kind of cool examples. One is the difference in how Europe is looking at fusion and quantum versus how the United States is looking at fusion and quantum. This is a whole nother topic, but it's super interesting because that's a race that we are all benefiting from and we're going to benefit from. It doesn't matter who wins that race, because we're going to solve the environmental problem like when that happens. And we know in our conversations with both of the top two companies, that's going to happen within a 10 to 15 year period, which makes the climate tech people, of which I consider myself one, very happy. We also very much like the dual use companies in both sense of the word, that have this climate tech embedded, and people often say to me, what does dual use or defense tech have to do with climate? Everything. And the next gen technologies take that climate piece for granted. They're building technologies where climate is not an afterthought. It's already built in. So that's the kind of thing we like. And we also, in Europe, we've got a big catch-up game compared to some of the things that the US has already done. However, it's an industrial, especially Germany where I am, it's an industrial nation. We've got loads of interesting aerospace companies. We've also got some satellite companies, one called Marble Imaging, which is really Europe's kind of answer to a Starlink, which is super important. Like, we need to have these kind of competitors to make sure that we're all sort of protected, that not one company can turn off the switch.
And certainly the energy conversation has become very important right now as we're looking at AI compute power and the amount of energy that's needed to support that. And so now we're building data centers next to wind farms. So don't take down the windmills yet, because we need everything that we can get our hands on, nuclear, I'm sure, everything, in order to feed this demand that we're seeing right now. And then we will build those data centers in space.
In the F1 track.
Yes.
In the
I want to thank you all for joining us on this extraterrestrial.